Hello and welcome. In this video we're going to talk about dynamic stochastic general equilibrium models. This lecture is based on the Keynesian model. And we will see how one distortion, like sticky prices, can be offset with one instrument. So the optimal monetary policy stabilizes both output gap and inflation with no trade-off. This is the divine coincidence concept, a concept elaborated by Blanchard and Galli in 2007. Then more rigidities are needed to explain policy-relevant trade-offs. Today, we will talk about rigidities in the labor market. So let's begin with the new Keynesian Phillips curve. We have a model where inflation is associated with expected inflation and with the output gap. And we have beta and kappa as parameters. The other agent in this economy is firms. We have a standard Douglas production function where the marginal cost is associated with the nominal wage and the marginal productivity of labor. In the other side we have consumers with the standard utility function. The optimal allocation for firms and consumers is defined by the first order condition. So in equilibrium, the marginal productivity of labor is equal to the marginal rate of substitution, and that is what we call the first best. We can develop this equilibrium using the production function, and we use the subindex 1 to define this first optimal allocation. Under the flexible price equilibrium, that is the second best, we assume P and W salaries prices flexible, and we introduce monopolistic competition for firms. But the optimal price setting rule here is that P is equal to the marginal cost, including the markup of the price of the cost, associated with the elasticity of the demand curve. So let's find out the equilibrium. Using the definition for the marginal cost of firms and combining the first order condition for consumers and firms, we have the optimal level of output under the second best. So here we use the definition of the marginal cost of firms and the marginal rate of substitution for consumers, and we find the equilibrium using the production function, and we can get the level of Y2. So now remember, using the two definitions of the production function for the first best and the second best, and using the definition for N1 and N2 under the first best and the second best equilibrium conditions, we can build the gap between the two levels of output. And as we can see here, the difference between Y1 and Y2 is constant. This will be very important for the result of the divine coincidence. So now let's introduce price rigidities allocable. Inflation is a function of the future inflation and also of the markup and the marginal cost, where lambda is a function of the percentage of fixed prices in this economy. So the goal will be here to find an expression for the marginal cost, but also an expression for the markup using this setup. So here we're finding an equilibrium for the marginal cost, and now we're going to find out what is the expression for the markup. So using the definition of the production function under the second best, we can find the final expression for what is the markup in this setup. So now that we have the two expressions for the marginal cost and the price markup, we can include those in the definition of the new Keynesian Phillips curve that we had before. So remember that the inflation is associated with the future inflation and also with the marginal cost and the price markup. So we replace those two expressions in the Phillips curve. We have this expression for the New Keynesian Phillips curve. So we can see here that stabilizing inflation is absolutely equivalent to stabilize the output gap. And we know that this also will be equivalent to stabilize the relation between y and y2. So as a conclusion, stabilizing inflation is absolutely equivalent to stabilize the welfare relevant distance of output from the first best. And this is what we call the divine coincidence. So one way to restore the trade-offs for monetary policy is by incorporating weight rigidities. So let's introduce this rigidity in terms of the real wage using the partial adjustment model that is associated with that the level of wages is associated with the previous level of wages and also the marginal rate of substitution, where gamma is the index of real wage rigidities. In this scenario, what we have as a flexible price equilibrium is that the salaries are associated with the previous level of salaries, but also with the function of the production function. So in for firms, the wage setting is that wages are equal to the marginal cost plus the marginal productivity of labor, but the marginal productivity of labor is obtained using the production function. And then if we substitute those expressions in the equilibrium for firms, we can finally get an expression for the salaries. So in summary, we have an expression for the equilibrium of the salaries for consumers and firms. So now remember the Pareto optimal allocation. We will use some of these expressions in the following definition of the optimal flexible price equilibrium under the second best. That is the equilibrium for consumers and firms. So after some algebra, we have this equilibrium condition or dynamics between y2 and y1 associated with the optimal spread between y1 and y2, which is delta. So in this expression, what about the gap between the first and the second best? So as we can see here, this gap is no longer constant. So the gap between first and the second best is not constant when you have gamma bigger than 0. So that will depend then preference and supply shocks. So now we include the price equilibrium a la Calvo using the production function from firms and the equilibrium condition of the firm, the first of the condition, and the last expression for the dynamic of salaries. And we can see after some algebra that there is a relation between the markup and the marginal cost across time that is associated with chi2, and that chi2 is not constant. And working a little bit the expression for the dynamics of the markup gap and the marginal cost and using the lag operator, we can find out a relation between the inflation and output gap implied by the model, which is this. So now the divine coincidence no longer holds. In detail, if the central bank targets inflation, like a constant level of inflation, then y minus y2 is also constant. But stabilizing y minus y2 is no longer desirable because what matters is the difference between y and y1. And now y1 minus y2 is no longer constant but instead affected by the shocks.